Local. Our lecture today is how to prepare anesthetic. Local anesthetic or painkillers are a diverse group of drugs that induces insensitivity to pain. The administration of anesthetic is necessary to provide inhibition of individual pain pathways or to render a patient unconscious so that surgical procedure can be carried out without pain. Over the years, hundreds of new local anesthetics have been synthesized and tested. Most have not common in general use. The search for perfect local anesthetic is still underway. All the anesthetics found to be active have certain structural features have certain structural features in common. At one end of the molecule is an aromatic end, at the other is a secondary or tertiary amine. These two essential features are separated by a central chain of atoms, usually 1 to 4 units long. The aromatic part is usually an ester of an aromatic acid. The ester group is important to the bodily detoxification of these compounds. The first step in deactivating them is a hydrolysis of this ester linkage, a process that occurs in the blood stream. As we know before, that ester linkage can be easily hydrolyzed under basic or acidic conditions. Compounds that do not have the ester link are both longer lasting in their effect and generally more toxic. An exception is lidocaine, which is an amide. The tertiary amino group is apparently necessary to enhance the solubility of the compounds in the injection solvent. We have to remember that benzocaine can't be used for injection, just can be used for as local anesthetic. Most of these compounds are used in their hydrochloride salt forms, which can be dissolved in water for injection. Benzocaine, in contrast, is active as a local anesthetic but in not used for injection. It does not suffuse well into tissue and is not water soluble. It is used primarily in skin preparations, in which it can be included in an ointment for direct application. It is an ingredient of many sunburn preparations. We can see from this slide the structure of benzocaine, which is contained an ester part which is essential in the hydrolysis process of the compound, and the aromatic part and the amino part which is essential to increase the solubility solubility of the compound when it is used. Benzocaine can be synthesized by direct esterification of para-amino benzoic acid with ethanol. In this experiment, a procedure is given for the preparation of a local anesthetic, benzocaine ethyl amino benzoate by Fischer esterification of para-amino benzoic acid with ethanol. Benzocaine is a short-acting local anesthetic used in a wide variety of clinical situations, including mucous membrane anesthesia, gag reflex suppression, anorectal disorders, and various pain syndromes. It is available in many dosage forms, including gels, creams, ointments, lotions, aerosols, and lozenges. It acts by interfering with the ability of certain nerve cells to conduct electrical signals. Specifically, benzocaine acts by acts by blocking sodium from centering the nerve cell ending at the site of pain, thereby preventing electrical signal transmission along the nerve fibers to the brain. This is the scheme of the preparation of benzocaine. The reaction catalyzed by few drops of sulfuric acid. This is the para-amino benzoic acid. Ethanol, the catalyst is sulfuric acid to prepare or produce benzocaine. The procedure includes putting of 0.5 gram of para-amino benzoic acid in a 250 ml round bottle flask and add 65 ml of absolute ethanol. Shake it gently to help the solvation process of the solid. We can see after the shaking process, not all the solid can be dissolved. The reaction is exothermic and we need to cool the mixture in an ice bath and add 5 ml of concentrated sulfuric acid. A large amount of precipitate will form when the sulfuric acid is added, but this solid will slowly dissolve during the reflex that follows. Set your reaction to a reflex condenser and heat the mixture under reflex on a steam bath. Avoid using fire because you have flammable solvent, which is ethanol. Remove the mixture after 2 hours and leave it to cool. Transfer the contents to a 400 ml beaker and add in small portions a diluted sodium bicarbonate solution 10% to neutralize the mixture. After each addition of the sodium carbonate solution, CO2 will be liberated. When no gas evolves, as you add a portion of sodium bicarbonate, stop the addition process. Check the pH of your mixture should be 9 or over. Thicken the aqueous mixture away from any solid formed from neutralization, pouring it into a separator funnel 250 ml or larger. Add a 100 ml of ether to the separator funnel and shake vigorously. Separate the mixture and save the upper layer. Dry it with magnesium sulfate anhydrous. Remove the drying agent by filtration. Ignore the solid. Remove the ether and ethanol by evaporating them over a hot plate in a hood. When most of ether and ethanol by evaporating them over a hot plate in a hood. When most of the solvent has been removed, about 5 ml remaining, and oil will be visible in the flask. Add 95% ethanol and heat the mixture on a hot plate until the oil dissolves. Add water to the alcohol solution until the oil again appears, and then cool the mixture in an ice bath. Collect the benzocaine by vacuum filtration using a Buchner funnel. The solid has dried overnight at room temperature on a piece of filter paper. Weight, calculate the percentage yield and determine the melting point of a pure benzocaine. You can do IR or NMR test to ensure that the solid you gain is a desired compound. Questions. What is the structure of the precipitate that forms after the sulfuric acid has been added? The answer is when number 2, when 10% of sodium carbonate solution is added, a gas evolves. What is the gas? Give a balance equation for this reaction. What do you put in the round bottom flask prior to starting the reaction? We have to put starting materials with boiling chips to avoid overheating. Number 4, after the reaction is done, the sulfuric acid is quenched and the pH is above 8. Why? Because you know that we have to remove sulfuric acid because the ester, benzocaine as ester, can be hydrolyzed by the concentrated sulfuric acid, which means that we have removed it by adding a base. Number 5, what mechanism type of reaction is used to synthesize benzocaine in our lab and why? Answer, bimolecular nucleophilic substitution reaction is used because the nucleophile is strong.